Welcome everyone, this is GEC 4, Mathematics in the Modern World. Today we will be having some introduction regarding this subject. This course is actually a prescribed subject by CHED, wherein this course is basically a math appreciation or mathematics appreciation course. As I said earlier, so this is a course that is prescribed by CHED. And based on the CMO number 20 provided by CHED, this course deals with the nature of mathematics, appreciation of its practical and intellectual and aesthetic dimensions, and application of mathematical tools in daily life. So, it is not stated that this course is a computation for course. Hindi tayo sobrang mag-compute dito, hindi tayo sobrang gagamit ng mga complex na equations. It's more on some ways or other perspective in which we will view mathematics. When we hear of the word mathematics, usually kasi ang unang pumapasok sa isip natin ay compute, arithmetic, add, subtract, kuha, differentiate ng equation, kunin ang derivative, uh, kunin ang integral, okay? Evaluate ang equation na ito. So, this course, hindi siya entirely puro ganun. So, this part of mathematics or this course on mathematics is not like that. This is not a torture. Mathematics is not made to torture. So, dito sa video na to, or in this video, you will see uh, an entirely different pros- uh, perspective of mathematics. Mathematics is the alphabet with which God has written the universe. This saying or these words came from Galileo Galilei, in which nakita ni Galilei na ang mathematics is somewhat the equation, somewhat the formula, somewhat the pattern, or somewhat yung isang buong abstract na bagay na nag-compute or nag-derive or nag-simplify, pwedeng mag-simplify or mag-model ng buong universe. So, nabanggit ko kanina, pattern, equations. So, by entirety, mathematics is actually created by nature. So, mathematics is created by nature. So, hindi naman entirety na yung concept or yung mismong knowledge or yung saklaw ng mathematics ay nature mismo yung ibig lang nating sabihin dito, yung understanding natin or yung knowledge natin sa mathematics is actually modeled and maybe observable in nature. So in that, yun na nga, pag-uusapan na natin ang mathematics. And by that, we will start with the definition of mathematics. So before that, before tayo mag-jump into that pattern or that formula or that equation, ito muna yung ilang mga definitions ng mathematics. Mathematics is a or on as a set of problem-solving tools. Ito yung kalimitan nating nakikita or na-encounter na view or perspective or side ng mathematics. So, it is the study of patterns. Mathematics is also a language. Mathematics is an art. It is a process of thinking, and it is also a science. But for this juncture or for this part of our course, we will view this yung sinabi ni Galilei na uh, yung mathematics ay alphabet kung saan isinulat ni God ang universe, we will see mathematics as a study of yun yung titingnan natin na view or titingnan natin na side ng mathematics. So, I have here a sequence of numbers, a pattern, as you will say. So, we have here the numbers 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 140. This sequence is first described by Indian mathematics in about 1300 years ago. So, ano bang meron dito sa sequence na 'to? Kasi maganda kasi yung sequence na 'to. So, paano na siya naging maganda? So, paano natin makukuha yung sequence na 'to or paano siya nag-view? So, yung may start at let's say at an arbitrary number 0. So, ginagawa lang dyan, para makuha yung next na number, you just need to add the two previous numbers. So, we have your 0 plus 1, that will be 1. So now, if we add 1 plus 1, we will have 2. Now, if we add 2 and 1, we will have 3. And the patterns, and this pattern goes on. So, paulit-ulit lang ang mangyayari, i-add mo lang yung dalawang previous na number to get the next term. Okay. So, yeah, in essence, this sequence is actually infinite. So, paanong naging na kumbaga, paano naging mainstream yung number? Nag-mainstream yung number pattern na yon due to one mathematician um, na tinawag na or named Leonardo Pisa or popular sa pangalan na Fibonacci. So, that sequence is actually what we call the Fibonacci sequence. It was introduced by Fibonacci to the West in 1202. So, it is all, si Fibonacci, yan yung picture niya, inintroduce din niya ang pagsusulat ng numbers using Arabic numerals. Yung nakasanayan na natin 1, 2, 3, and so on. Hindi na yung Roman numerals na I, 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 na po. So, ayan po. So, Fibonacci also written the book Liber Abasi, which deals with rabbit numbers. So, use Fibonacci used this sequence to describe the population growth of rabbits. So, at first, you may think na meron kang isang rabbit, isang male na rabbit, isang female na rabbit. Once na nag-mate yung dalawang yun, they will have another rabbit. So, bale nangyayari doon, first rabbit, the second rabbit, yun yung dalawang mong rabbit. Nagkaanak sila ng isa, that will be 3. Now, kapag yung 3 na yan ay nagkaroon na, nag-mate din, pwede kang magkaroon ng dalawang bagong offspring, so that will be 5. And yung dalawang 5 na yan, once na nag-partner up sila, sa pairing na yan, pwede kang magkaroon ulit ng tatlo pang rabbit, so magkakaroon ka ng 8. So, dito naman sa 8 na to, kapag nag-partner up sila, magkakaroon ka ulit ng another 5 na, na offspring. So, that will be 5 plus 8, that will be 13. And, nag-follow na yon or nagtuloy-tuloy na yon sa ganung sequence. So, hindi lang naman sa rabbit nakikita uh, ang ating Fibonacci sequence. This pattern can also be seen in nature. So, ito yung ilang examples. So, I have here flowers. I have here a flower with one petal. And that will be your So, ano bang isang importanteng bagay na meron dito sa Fibonacci sequence? Here in Fibonacci sequence, we can actually do some mathematical operations where if we are to get the ratio of the Fibonacci sequence, we have here, if we divide mas mataas na number by the lower number, yung magkasunod lang, so we have here, if we divide 2 by 1, we have 2. If we divide 3 by 2, we have 1.5. If we divide 5 by 3, we will have 1.67. If we divide 8 by 5, we will have 1.6. If we divide 13 by 8, we will have 1.625. And the list goes on. If we divide 21 by 13, we'll have 1.615. 34 by 21, we'll have 1.619. 55 by 34, 1.618. 89 divided by 55 will have 1.618. 1.618. Continue. If we continue on doing that and consider the first three decimal places, mapapansin nyo actually na paulit-ulit yung 1.618, 1.617, pero pag round off natin, that is 1.618, 1.618, 1.618, 1.618, and 1.618, and so on. So what's up with that number? What's with 1.618? That is actually what we call the golden ratio. So if we are to measure certain measurements na mayroong ganitong ratio, may ganitong proportion, we are saying na yung number na yun ay within the golden ratio. So ano bang significance ng golden ratio? Golden ratio is or P is the ratio of consecutive Fibonacci sequence. It is used by civilizations far as back as ancient Egypt, Mayans, and Greeks, and it is considered as the nature's perfect number. So, in the past, kung nagme-measure ang ancient Egypt at ancient Mayan ng or ancient Greek ng isang halimbawa, isang brick or isang block, yung width ng block na yon at yung length ng block na yon ay dapat may ratio na 1.618. Yun yung sinusunod nila. So, maybe due to structural integrity, hindi natin alam kung bakit. Pero siguro, ibinase nila yon sa mga nakikitang ratio sa nature. Kaya nila sinusunod yun. Ito yung ano niya, yung illustration. So, kung meron kang width na ang measure ay 1, dapat yung length niya ay 1.618. Okay? So, ganun din yung pina-follow ng ibang ito. So, paano ba ito na-derive? Pakita lang natin. So, kung makikita nyo, itong block na to ay may measure na, itong square na to ay may measure na 1 by 1. So, 1. Okay? Another is, we have here 1 by 1 din. So, this is 1. Nag-add nyo yung length nito. 1 plus 1. This is actually 2 by 2. Okay? Try lang natin. Squares to lahat. So, ibig sabihin, kapag pinag-add natin itong 1 na to, 2 na ito, 3. Okay? So we'll have here 2 plus 3. We'll have here 5. Okay. So we'll have here 3 plus 5. This will be 3. Wow. So, Fibonacci sequence pa rin. Tama ba? Makikita natin dito na yung ratio na 1:1.618 or yung ating golden ratio follows the measurements of our Fibonacci sequence. So, this is hindi naman ito nakikita sa nature. So, anong significance nitong blocks na ito? Pero, this is actually the representation or what we say yung saan natin makikita yung ginawa natin. Actually, kung titingnan nyo dyan, dito sa gitna ng Nautilus, this is the shell of the Nautilus, one mollusk na pwede natin makita sa marine environment. Yung growth spiral or yung expand ng area ng spiral ng Nautilus follows the Fibonacci sequence. Okay? So, meron dun sa loob na yung measure ng cell or nung shells ay 1:1 yung growth. Tapos magkakaroon ng 1:2, 1:3, 1:2, no, 1, 1, 1, tapos mag-2, 1, 1, mag-2, 3, 5, hanggang sa umabot siya ng so on and so forth. But the measurement follows the Fibonacci sequence in such a way that the growth of the span or the width of the spiral is 1:1.68. Kaya siya nakikita sa nature. Kaya itong Nautilus, ito yung isa sa mga pinaka uh, pwedeng mag-represent sa Fibonacci spiral or yung ating golden ratio spiral. Okay, so saan siya ginamit? Ginamit siya sa painting. Pwede, kung titingnan nyo actually, kung mag-measure tayo mga bagay-bagay, diba, titingnan natin kung rectangle na ito. Maaaring itong rectangle na ito, mag-measure ng 1, or yung ratio niya is 1, 1, 3, 6, 1, 8. Okay? Titingnan mo yung span nung angel wings. Haba niya mataas. At yung haba niya papunta rin sa side. Maaari ring mag-ratio ng 1:1.68 or dito yung 1 taas and 1.618 sa baba. Also, itong mga images dito sa baba, maaaring itong width nitong table na to is 1 at yung height niya is 1.618. Yung length nitong head saint dito ay pwedeng 1.618 ang haba dito sa may belly. So, yun yung mga pwedeng applications na gamitin ng golden ratio. Ito pa yung ilan. Ito ay gawa ni Leonardo da Vinci. So, ito yung sa ratio ng katawan ng tao. So, yung length niya, yung span ng shoulders natin, sa height nung head natin is may 1.618 na ratio. Also, yung yung span ng arms natin, yan, ay at yung height ng tao ay may ratio na 1.618. by approximation. Also, pwede rin yung span nung shoulder hanggang sa may elbow natin ay 1:1.618 hanggang dun sa may pelvic part ng area natin. So, ganun din, ginamit din to sa art, yung ratio nung pagka-spiral or nung lean nung mga paintings ay ginagamitan ng ganyan. So, pwedeng yung main part ng painting, part na ito, ay ang ratio niya is 1.618 dito sa area na ito. So, yan yung gamit ng ating ratio sa iba pang art. Same with Mona Lisa. It is rumored, ay yung may mga studies regarding dito. Sa golden ratio na pwede makita yung Mona Lisa. So, kung i-check yung mga, yung mga ratio ng bawat parts ng katawan, mata, yung ilong, yung bibig niya, ay yung span ng lapad ng mukha niya, pwede niyo siyang makita. Ito pa yung ilan na pwede nating magamitan ng golden ratio. And for your assignment, you are to take a photograph of an object that seems to follow the golden ratio. That is all for today. Have a good day.